Hello everyone, welcome to another video. This is part 2 of chapter 10. So we're going to do a volume this time round. So we've seen this something similar in the previous video, so I'm going to go faster now. Okay, so the theory is the same. We're looking at the length and the volume. What's the link here? So if you remember my cheat sheet from the previous part, from the length to get the volume, I got to cube. So that's what this part is supposed to show you. You can see that this square, this cube has side all 1, right? So if you take the volume, it's going to 1 times 1 times 1, 1. So when it's 2, it's 2 cube. And then when it's 3, it's 3 cube. So really the link here is from the length to the volume is basically just cubing it. Once you cube it, you get the volume. Okay, so this will be the same formula with only one exception. Now it's volume instead of area, and now it's cube instead of square, because I'm changing from the length to the volume. I'm going to cube it. Okay, that's all. So in the same theory, I can cube the length to get the volume. I can also cube root the volume to get the length. Okay, so let's look at one simple example and how this is being used. So again, I have two similar shapes. It's similar here, right? Similar. And then I got a 4 and got a 12. I got the length. I don't know the volume. I have the volume. So I like to start with the unknown here, right? So it's a small volume divided by the big volume. So small divided by big. And then the small length divided by the big length. So 4 over 12. And in order to make it equal, you just got to cube the length. And then these two will be equal. So to solve for this V2, I multiply the 81 over. Come like this. And I get 3. Yeah, easy. Okay, so let's look at something else. So this will be still a very simple question. Just that there's no picture given to you. They sort of describe the whole thing only. So same thing, I have two similar, again see the similar clay figurine. One height is 45, one is 81. And then I'm supposed to find the mass. So the mass is actually a volume. And then where the height is actually a length. You've got to be very sensitive to that. Okay, so the bigger one is I need to find the bigger one, and then it's 27 gram. And now I need to find the smaller one. So that's the unknown here. So let's let the x be the unknown, and then same thing. I have the volume, right? So I let the x, the smaller one, over the bigger one. So it's small over big volume. And now I need the small height over the big height. So small over big. And then to get these two to be the same, I need to cube this. So I cube, and then to find the unknown x here, I simply again I multiply over. So soft. Okay, so this will be a slightly more complex question. But just before you give it a try, you can see that the only interesting here is 1/8. So the water here to the whole volume is 1 over 8. So which means the ratio is 1:8. So that's all you got to take note, and then you can give it a try. If you can't do it, you can always scan this and then you watch from there. Okay, I'm going to go on. So now this is a practice 2. This is for you to try yourself. You can take note that the answer is here. The answers are given here, and these two questions over here is very similar to the very first question that we did. So that will be here. Example 4 is exactly the same as example 4. So you should give it a try, because this is the bulk of the easy questions will all be like that. Okay, so let's go on to the next one. I'm going to go through this question. Okay, so again I have similar shapes, same material, and then the radius is 2 and 3. So the radius is a length, because the radius is just a length, right? And then I need to write down the ratio of the surface area of the smaller to the bigger. So I'm given the ratio of the length 2 and 3. Now I need area. So based on our cheat sheet over here, you can see that I'm given the length. I want the area, so I got to square it. That's why I start from here. 2, 3, and I square. So 2 square become 4, 3 square become 9. So that's the answer of the area. This is length ratio. Once I square it, I get the areas ratio. That's all. After that, I'm supposed to find the mass of the smaller one when it is 72, and I need the mass of the larger one. So this is volume, right? So I need to switch from this to 2:3, the length. So length, I need to switch it to volume. So I need to cube. So again I start with 2:3 and I cube both the numbers. So 2 cube is 8, 3 cube is 27. So this is the volumes ratio. And then it says that the smaller sphere is 72, right? So this number on the left is the smaller one. This number needs to change to 72. So what I do is, in my mind, I'm dividing by 8 to get 1, and then I'm times 72. So this number is going to divide by 8 and then times 72. So that's the answer. Okay, it's quite simple, right? So the next question, you will see that this is quite similar to the one before. Okay, is there a QR code? No, don't have. Oh my god. Okay, so we're going to go through this. So again, I have a cube. The side is 5 and then it weighs 200. So the side, the edge is the length. This weighing is the volume. So same thing, they ask you for the weight of a geometrical similar one. See, it must be similar. And then the edge is 5. So the ratio of the length is actually 5 and 8. Okay, and I want volume, right? So from the 5 and 8 is the length. I need to cube these two numbers. So 5 cube is this, 8 cube is this. And these two numbers will be the ratio of the volume, because I'm interested in volume now. And then, so when the edge is 8, which means it's the bigger one, right? So when the bigger one, how much is the bigger one when the smaller one is 200? So from this, I need to change the smaller one to 200, and then I see what's the answer here. So same thing, from this one, I'm going to divide by 125 and then times 200. So here I need to do the same. So this number divide 125 times 200, and this is the final answer. Yeah. Okay, so this one will be with a QR code, so I'm not going to go through too much. But the idea here is the whole container and the water, these two is always similar, and that's why you can use the things that we have learned so far. And then just to give you a hint, the first part of the this question has nothing to do with what we're learning. It is really just solving normally. Okay, so don't keep thinking that you're going to do some ratio thing. In this part 1, there's nothing to do with what we're learning now. Okay, so give it a try. My focus for this whole chapter will be this question. This is the hardest question. This is probably as hard as it can go. Okay, so this is considered very difficult. Okay, let's read this question in detail. So I have a cone here, all the dimensions given, and then it's filled with sand to 40. So this part is the sand. Okay, so again, this two shape is similar. The sand is, in other words, volume. All these are actually length. Okay, so what are we looking for? They say show that the radius of the base of the sand is 25 point something. So I want the radius. So this is the length, right? So I'm looking at this R here, and I already know that the sand and the whole container is actually similar. So I can do the ratio thing. So the ratio of this and 60, which is both the radius, right, must be the same as the ratio of the height and the height. So I start from here. So R over this is equal to this over this. So that's why I'm writing this here. And then to solve for R, I just times this over. See? Now the 60 times up, I solved and shown already, done. Okay. After that, I need to find the volume of the sand. Now this is the sand, right? It's clearly in the form of a cone, and all the numbers I have, I just found the radius here. So the volume of cone is 1/3 pi r square times the height. So you can see that it's 1/3 times the pi r square, this is the r square, times the height, 60. So that's where all the numbers come in. You press the calculator, this one, and then you round off to 3SF for the final answer. Okay, so for part C, I need to find the surface area of the container in contact with the sand. So in other words, it's just this bottom part, right? The whole round thing at the bottom. Now you must be careful. It is in contact with the container. So that means the circle on the top is not counted. In other words, I just want the so-called the curved surface area of a cone. So again, this formula is given to you in O levels. It is actually pi RL. So here, see, it's the curved surface area, which is pi RL. So pi and R, you know what is it, right? So what's L? L is actually the slanted side. Okay, so we need to find this first. So this is not very hard to find because you have the radius, you have the height. This is actually right angle triangle. You can use Pythagoras theorem, these two, to get this one. Okay, so I draw this over here. The radius, the height is a right angle triangle. So square square plus together is L square. So that's your Pythagoras theorem here. And then I solve. Okay, once I get the L, I just sub everything in, and that's the answer. Again, long decimal, 3 SF. Okay, so now let's go for the last one. The last one is the most difficult one. So this cone, now they're going to flip it over to become like that. So of course the sand from here will drop down, right? And then they ask you what's the height of the sand. Now this is quite difficult because this shape over here, the sand, has no formula. I don't even know how tall is the sand. And I don't know all the radius here, so it's impossible to find. So the plan is this. What I'm going to do is, I need to find, you can see my plan here. My plan, the H, this H over here, is going to be the full height. So the full height of the cone, which is 140 here. And then I'm going to minus away the so-called empty height. So I'm going to find the height of this empty space. Okay. So what I'm going to do is I find the whole volume of the cone, I minus away the volume of the sand. Then I know what is the volume of this empty part. And then I work backwards because this is a cone shape. I can work backwards to find it. Okay, so the long story short, I first find the whole volume of the container, which is the 60 and the 140, so it's from here. The 60 is the radius, the 140 is the height. So this is the full volume, and then I'm going to find the volume of the space. So I already have the sand, right? So if you look at this one, I have the volume of the sand, is part B, so it's this one. So I take the full volume, minus away the sand, I get this one. So this is the so-called empty volume, so empty space lah. I get this. Then what I'm going to do is, now that I have the volume, so this is the full volume, this is the empty space volume. So space and the full, this is the two numbers, volume, right? I want to go for the height, so I need to cube root both of them, right? So it's again based on this cheat sheet over here. I have the volume, I want to go back to the length, I need to cube root both numbers. That's why I'm cube rooting these two. See, I'm cube rooting, and now I get the length. And once I get the length, the bigger one needs to be 140. So I need to change this to 140. So again, it's divided by itself times 140. So here, divide by this number over here times 140. It looks very scary, I know. And then if I press the calculator, I get 136 point something. So, okay, so that means this 136 point something is over here, this height of the empty part. So I just need to take the whole 140 minus the 136 point something. I minus, and that's the 3.77 answer. Okay, so this is considered very difficult. You shouldn't be seeing this very often, even in O levels. If you see it, then you're quite unlucky lah. So that'll be the difficult one lah. Okay, so now you have two homeworks you can try. So give it a try. Hopefully you can clear this chapter quickly, so we can move on to the next one. Okay, so hope you have learned something new today. Thank you and bye bye.